Hello, this is Professor Reena Randir. Today we'll talk about climate change, energy, and sustainability. The main learning objectives is for us to differentiate what climate change and global warming is. We'll also discuss the sources and effects of the different greenhouse gases, how greenhouse gases correlate to rising global temperatures and the consequences of that. We'll discuss renewable energy and how to mitigate climate change. We'll learn about carbon sequestration and carbon capture and some of the pledges and sustainable solutions for mitigating climate change. Here's a very interesting map. So this chart shows the increasing human population for the last 12,000 years. And you can see since like the 17th century, 18th century, there's a exponential growth of the human population. And here's the map that shows a graph that shows as the population increases, the demand for fuel also increases. And if we talk about the old-fashioned high carbon emitting fossil fuels like coal, it is expected to will run out of coal in 150 years, natural gas in 50 years, and oil also in 50 years. We can't afford to use, even though it's available for the next 50 years, we can't afford to use it because it's dirty energy. It is polluting the environment and causing climate change. We do have uranium that burns cleaner, but we have it only for 90 years. So it is not completely renewable, but it is clean. When you say greenhouse effect, it refers to the heat that is trapped very close to the Earth's surface because of the blanket of greenhouse gases. We do need this blanket though at the allowed levels. So you can see how all the energy for Mother Earth is from the sun. So the solar radiation comes from the sun. Earth will absorb some, reflect some, and re-emit some, and so forth. So that is normal. It always has been happening. But because of modern industrialization, high pollution, there's more harmful gases. And because of this high heat energy, instead of being radiated back into space, it bounces back and forth in the Earth atmosphere, causing global warming. So when we say global warming, we refer to temperature increase. Climate change talks about changes in climate over a long period of time. It's not only temperature, but also precipitation and wind patterns, all the weather patterns. And climate change is actually very complex because it is caused by a lot of interactions between humans and also natural processes. So it is not one cause and one effect. It's very complicated. One of the most powerful ways we have to address climate change would be to use sustainable clean energy. Meaning we have to meet the needs of today without compromising the ability of future generation to meet their own needs. So we need clean energy that is renewable. So that's why the importance of our class. And here's the important concepts to remind ourselves of. It's the Earth's energy budget. This refers to the balance between the incoming and outgoing energy of the Earth. So here, out of the 100% of solar energy that hits the Earth, all the yellow arrows are showing reflection. Some is going to be absorbed by the Earth, by the air, clouds, and so forth. And then here's the ones that are radiated back into space. So this balance is a very delicate balance. And this is what will determine all the energy flows in the ecosystem. So when the amount of energy coming in is more than the amount of energy is that's going out, this will trigger the planet to warm up. That will result in climate change. That has very bad consequences. See, this scenario is almost like going into debt, spending more than what we can afford. So, what are the greenhouse gases? Carbon dioxide is the most important anthropogenic greenhouse gas. The problem with carbon dioxide is that it lingers in the atmosphere for hundreds to thousands of years. That's very serious. The top six greenhouse gases, according to the Kyoto Protocol, is carbon dioxide, methane gas, CH4, nitrous oxide, perfluorocarbons, hydrofluorocarbons, and sulfur hexafluoride. There's also other greenhouse gases like ozone, bromine compounds or halogens, CFCs, and also water vapor. In this graph below on the right, it shows the fluctuations in the carbon dioxide, and you can see how in recent times the amount of carbon dioxide due to industrialization and burning fossil fuels has like exponentially increased, and it's increasing. So that's why we have to address this. There's an urgency for this. So which sector is causing the most pollution? Which sector is putting out most carbon dioxide in the atmosphere? It's the energy sector. So 73% of the global greenhouse gases will come from the energy sector. So that combines industry, transport, and energy use for buildings, heating and cooling buildings. Agriculture and forestry is only 18%. The rest, 8%, comes from other like landfills, waterways, cement factory, that's serious, and so forth. So keep in mind, energy is 73% of the carbon dioxide emission is contributing. This is the reason as to why the next step is renewable energy, clean energy. So this chart shows which country is causing the most pollution. So it is most pollution is caused by China, followed by USA, and then India. But if you talk about per capita pollution, carbon dioxide pollution, it's Middle East, all the rich countries, Canada, Saudi Arabia, and USA. USA also has a very high per capita carbon emission. This picture is showing the world energy injustice. It's called energy poverty. So here people in the pink, so you can see they are very poor. The GDP is very low, and they lack access to energy. They don't even have a stove to cook their food. They are very poor. And this end of the chart is where climate change is most severe. The infrastructure of the country is so poor. So when there's a tornado or like a wildfire or tsunami, it's very, very hard for this poverty-stricken people to jump back. Whereas on the other spectrum, here there's rich countries, USA, Canada, Switzerland, and all of the many European countries, the GDP is very, very high. They have a very affluent lifestyle. And these countries are the ones that are polluting the atmosphere. So, that's why injustice. This is a injustice to humanity. So these rich countries, when there is a natural disaster that is driven by climate change, they have an infrastructure to bounce back. They are rich countries. This graph is showing the connection between the increasing carbon dioxide concentrations and temperature. So this data is from NASA. So it shows that the Earth's average temperature has risen by 0.8 degrees since 1880. And over the last 150 years, carbon dioxide concentration has jumped from 280 ppm to 380 ppm, parts per million. And this coincides with burning more fossil fuels. So what did that lead us to? It led us to catastrophe all over the world. So here, this picture also is from NASA, and it is showing the loss of ice in the Arctic Sea. The polar caps are melting at an alarming rate, losing at a rate of 13% per decade. So over the last 30 years, the thickest parts of Arctic has declined by 95%. So what does this mean? So temperature is increasing, so water expands, so the oceans are rising here. So we are losing ice, we are losing the habitat of all the wildlife that live here. So we've seen pictures of the polar bear, right? There's a habitat loss. And now their behavior has changed. In recent years, there has been a lot of cannibalism in polar bears. Polar bear mothers eating their own cubs. So these are all like changes in the way life works. So there's changing rain and snow patterns. I remember a few years ago, we had snow for Thanksgiving in New England. The storms are stronger and they are more frequent. We have extensively damaged our coral reefs because the oceans are becoming acidic. And so carbon dioxide can dissolve in the water and cause the oceans to become acidic. And because of this, coral is very, very sensitive to pH change, and we are losing a lot of coral. The migration of birds have changed. Birds that migrate from Central America to Canada, they don't go to Canada anymore. They just stop short of New York. There's more heat waves. Our elderly people, there's more deaths because of heat waves now. Rising sea levels. The oceans are warmer. There's more droughts and fires. Our permafrost is thawing. Our plants' life cycle is changing. They are blooming much faster. A zone 5 is now a zone 6 in certain places. Here's a picture of rising sea levels. So here's a graph. So we have the levels have risen like 8 to 9 inches since 1880. And in the last 20 years has been the worst. So you can see so this is Plum Island in Massachusetts. So you can see property damage here. The sea level is rising and all these houses are like right there. The water is right to the doorstep. This air pollution, extensions, this wildlife extension is really a very sad story. Global warming is if this continues, we are going to lose about a third of the Earth's animal and plant species. They will go extinct by 2050. South America has the highest extinction rate of 23%, followed by Australia and New Zealand. And this beautiful golden toad is already extinct. See, 1989. And that was directly related to changing weather patterns. And we know that there are so many animals like panda bears and leopards and tigers. They're all on the endangered list, and there's a lot of conservation efforts that's happening right now. So the causes for climate change is industrialization, heavy energy use and reliance on fossil fuels, and also agricultural practices and deforestation at an alarming rate. Over consumerism, over the diet shift to eating a lot of meat. Transport, that's why they talk about carpooling. Over extraction of natural resources and intense pollution. One thing to keep in mind is when people talk about climate change, climate change has been happening, since we started collecting data. So since the Earth formed. So you can see how the carbon dioxide content goes up and down, up and down. So this one reason for this is explained by the scientist called Milankovitch. So he proved that the changes in the orbit of the Earth, right? It's called eccentricity, orbit around the sun. That shifts the wobble. There's a little bit of wobble around the axis that changes, and the angle of tilt, the changes in obliquity. So these are also responsible for climate change, but not to this extent. Not to this extent. When you calculate the ecological footprint of developed countries like USA, Australia, you can see, like, you might have done an activity where we measure the ecological footprint. So it refers to the population's demand on nature, and it is compared to the biocapacity. For example, in USA, the ecological footprint is 8 hectares per person, whereas the carrying capacity, biocapacity is only 3.4 hectares. And this trend is not sustainable. Whereas if you take like ecological footprint of a poor country like Sierra Leone, see here, Cuba, India, Sri Lanka, so all these third world countries are here. Their footprint is low, and they also like the human development index is very, very low. What is human development index? This was set by the United Nations. It's an indicator of human development in terms of how long a person lives, how educated they are, and how rich they are. So the human development index is very poor in low ecological footprint countries. Again, this is kind of an indicator of the injustice in the world. So the solution, I mean, we have no other choice, is to transition to clean energy. And not only transition, we also need innovation and a focus on fuel efficiency and conservation. Because the way we are doing things now is not sustainable. And then this is what led to the climate crisis. The climate crisis led to climate action towards a sustainability and a net zero carbon emission. And here's a recent picture of President Biden. He has pledged that USA will halve its carbon emissions so that it will keep the 1.5 degrees Celsius growth within reach. He has pledged to double US support for developing countries and triple finance for adaptation efforts by 2024. So this transition to clean energy is inevitable, it's necessary, and science, the technology innovation part will play a huge role. So politicians standing up for climate action is very, very important. So what are some of the shifts that we should see very soon is we have to move away from fossil fuel and go into renewables, and also develop technology to capture the carbon dioxide from the atmosphere and store it away, like somewhere deep under the earth. We should have more fuel efficient transportation, green buildings, energy efficient appliances. We just all of us need a mind change. Since climate change is very, very complicated, right? I told you several times, climate change is not caused by one reason. To address it, we need an integrated solution. The whole world must come together. Industry, the commercial, individual people, all of us must come together in order to find solutions. And here's an action plan for some city that I found online. Another promising way to reduce carbon emissions is something called carbon pricing. So what is carbon pricing? It is a cost that is applied for greenhouse gas emissions. So if you are polluting, let's say an industry is polluting the atmosphere, tax them. So this will encourage the polluters to reduce fossil fuel use, right? So here's a very good case study. So it was in 1991. Sweden was the first country to implement the carbon tax. And since they increased the carbon tax, carbon emissions reduced by 29%, which is remarkable. And this trend was seen in many other countries also. So we have a tool that works. Carbon sequestration. So this is to capture the carbon produced by fossil fuels and storing it somewhere away. So you will see carbon capture technology come up in the near future. So this refers to carbon capture, sequestration, and storing it maybe deep under the earth. So that we have the technology. It is called, one is the most popular, is called amine scrubbing, in which the carbon dioxide containing flume will pass through amine compounds, which will absorb the carbon dioxide. And then after it absorbs, it will be stored somewhere very deep under the earth, maybe slits in the rock, or maybe it can even be changed into a solid, stored under water and so forth. So this is what it looks like. It's a very promising technology. Carbon sequestration also through increasing photosynthesis in the world. See here in the NASA world map here on the left, everywhere you see green, it's photosynthesis happening. So how do you account for the green in the oceans then? So it's not only trees and vegetation that can do photosynthesis and capture atmospheric carbon dioxide. There's also some protist, or it is algae that can perform photosynthesis. So if you study this equation of photosynthesis, here's carbon dioxide combining with water, and in the presence of photons of light is able to make glucose and oxygen. I love this equation. So the two things we need for survival, food and oxygen, comes from plants. And here's a plant of a protist or algae, which is pond scum. So this is the idea behind planting trees and reforestation efforts all over the world. And this was last year. Here's my student Olivia planting a tree in one of the parks here in Springfield. So this is a very simple technology that you and I can do, and it has a lot of benefit. So what about the future for USA? So there's lots of pledges and plans and policy in place to shift from fossil fuel to, see, everything here in the blue is renewable energy, wind, solar, biomass, hydrothermal, nuclear, and so forth. So there's a shift from dirty energy to clean energy. And also you can see carbon capture picture here, and also efficiency of our energy sources. And here in transportation, again, a shift to hybrid cars and clean energy cars. Technology, energy efficiency. So more green buildings and buildings that can conserve energy and not use fossil fuels for heating the buildings. Carbon capture, so more technology for carbon capture and vehicle efficiency. Here there's the acceptance for nuclear energy is higher now, which is a very good thing. So you can see more nuclear reactors in the future. And biofuels, using waste organic compounds. It's fermented. They'll make methane gas that is burned to run generators to make fuel. And now we are hoping to see a shift in transportation fuel to biofuels, especially for aviation and huge ships. So what can you and I do? We can demand climate change from our politicians, bravely speak up. We can do what we can in our home to become, our home should be net zero carbon emission. We have to weatherize, invest in energy efficient appliances, reduce everything, reduce our water use, our food use, eat more vegetarian food, buy better bulbs, unplug your appliances. So we've seen this, right? Reduce, reuse, rethink, recycle. All these are powerful changes we can do in our everyday lives. Active citizenship, climate leadership. I hope you'll start thinking about these things because all these things matter. And here's a very promising picture of USA emissions control by 2050. So this is from the White House webpage. So here, if you see, by 2050, more than 85% of the buildings will be net zero carbon. 90% of industry will be low emission. 70% of the electricity will come from renewables. So if we could just follow through on the pledges, if all the countries follow through on the pledges, yes, we can mitigate climate change. And this is also a very optimistic picture. And you can see from 2020 to 2060 here, 2050, all I see is, windmills and solar energy and hybrid cars and renewables, clean energy. So this shift is already happening and it should continue to happen. And I hope you found that interesting and helpful.